Hi guys, this is Organic Nomenclature and we will be naming benzene and its derivatives. Benzene is a hydrocarbon with the molecular formula of C6H6 and a skeletal formula displayed in the form of a hexagon with a ring in its center. So this is what benzene is. And if you look at the displayed formula of benzene, we've got six carbon atoms forming the hexagonal cyclic ring, and each carbon atom is bonded to a hydrogen atom. So this is what the molecule of benzene looks like. Now, if we have substitutions taking place on the benzene ring, a hydrogen atom will be replaced by an atom or a group, for example, chlorine or methyl group, and the name of the compound would be given accordingly. Now, whichever carbon atom has the substitution taking place on it will be numbered as the first carbon atom. So, if we have the benzene ring with a CH3 placed here, so this would be numbered as the first carbon atom, and the name of this compound would be methyl benzene. Now, if the methyl group is placed on any of the six carbon atoms, that carbon atom would be called the first carbon atom, and the name of the compound would remain methyl benzene. For ease of writing, normally the substitute group, if it is only one, is written at the top, just like in methyl benzene as shown. So, if we have a chloro group present on the benzene molecule, so this will be the first carbon atom, and the name of the compound would be chlorobenzene. Next, we would have a Br atom attached to the benzene molecule, and the name of this compound would be bromobenzene. Similarly, if we have an ethyl group CH2, CH3 attached to the benzene ring, the name of this compound becomes ethyl benzene. We can also have an NO2 group attached to the benzene ring, and this compound would be called nitrobenzene, since the NO2 group is known as the nitro group. Now let us look at multiple substitutions taking place on the benzene ring. So if we have a benzene ring with Cl and a BR placed on it. Now, the preference of naming will be in accordance with the alphabetical preference of the substitute group. So, the name of chloro begins with a C and the name bromo begins with a B. So, B will be given preference over C. So, the numbering would start with the carbon atom having bromine attached to it, and the least number will be given to the next substitute group. So, in this compound, the numbering would be done in the anti-clockwise direction. So this will become the second carbon atom. And the name of this compound would become bromo. We will not mention the first position because if we just write bromo, it automatically means that it is on the first carbon atom. But chlorine is on the second carbon atom, so the name would become bromo 2-chlorobenzene. Next, we have a benzene ring and we have a methyl group on it. We have a nitro group on it. So numbering would start from methyl because M comes before N. So 1, 2, 3, 4. Now the thing is, if we number it clockwise, the way it has been done, or anti-clockwise, nitro group will be on the fourth position. So it doesn't matter whether we number it clockwise or anti-clockwise in this compound. So the name of this compound based on the positions of the substitute groups would become methyl 4 nitrobenzene. Another compound would be a methyl group, a chloro group, and a bromo group. So now in this case, again, alphabetical preference would be given to bromine. So the numbering would start with the carbon having the Br attached to it. The second carbon would have methyl, and the third would be the one having chlorine on it. But when naming this compound, we would start with bromo 3-chloro. Since C comes after B, then we get 2-methyl benzene. So like this, if we've got multiple groups present on it, we name it according to the alphabetical order. This is also true if we have got similar groups present on the benzene ring at multiple positions. For example, if we have CH3, then we've got two nitro groups attached, one on this position, the other here. So the numbering would start from the methyl group because M comes before N. So we have one, and then two, three, four, five, and six. If we number it clockwise, we get nitro groups on the 2 and the 6th position. Or if we number it anti-clockwise also, we get the nitro group on the 2 and the 6th position. So the name of this compound would be methyl 2, 6 dinitrobenzene. Next, we would have a compound in which we have four substitutions. So we would have the benzene molecule placed this way, and I'll place an NO2 here, a CH3 here, a Cl here, and a Br here. So now we've got four substitutions, and based on this, now we've got a choice. We will begin with bromine because B comes before the C of chloro, M of methyl, and N of nitro. And now, if we continue numbering, so if we number it anti-clockwise, the second position goes to the N of nitro. And if we label it, that would be clockwise. If we label it anti-clockwise, we get the M of methyl. So if for the second position, if we have a choice between the M of methyl and the N of nitro, we would go with the M of methyl. So this compound would be numbered anti-clockwise. So 1, 2, 3, 4, 5, and 6. And the name would be written in alphabetical preference. So we begin with bromo. So it would be bromo. Then we have 4-chloro. Then we've got 2-methyl. Then we've got 6-nitro. This completes all the four substitute groups present on the benzene molecule, and name of the parent compound comes in the end, benzene. If substitutions take place on the benzene molecule, then we call the parent compound as benzene. But if benzene is present as a substitute group on another organic molecule in which a different functional group is present, then benzene acts as a substitute group. So now we're going to look at benzene as a substituted group. And we need to remember that benzene as a substitute group will be called phenyl. Just like OH as a functional group is called alcohol and OH as a substitute group is called hydroxy, benzene as a substitute group will be called phenyl. So if we have an alcohol, for example, CH3OH, that is methanol, if we replace one of the hydrogen atoms in the CH3 group in that alcohol with a benzene ring, then this is a single carbon containing alcohol and a substitute benzene ring on it. So the name of this compound becomes phenyl. Because there is only one carbon atom, we do not need to place the position. So this is phenyl methanol. Similarly, if we have a carboxylic acid, so COOH, then we've got CH, then we've got a CH3, and we place the benzene ring here. So numbering of carbon atoms begin from the COOH carbon in carboxylic acid. So 1, 2, and 3. So the name of this compound becomes 2 phenyl propanol, or actually propanoic acid. Propanoic acid. Now, since I've just mentioned an aldehyde, let's look at an aldehyde with the substituted benzene ring on it. So CH3, C. Let's place two groups here: a chlorine atom and a benzene molecule. And then we've got CHO, making this an aldehyde. So the numbering begins with the CHO group 1, 2, and 3. Now we have got a chlorine atom at the second position and a phenyl substitute group at the second position. So the alphabetical preference will be given to chlorine during the naming of this compound. So the name of the compound becomes 2-chloro, 2-phenyl, and 3-carbon atom aldehyde is known as propanol. And if we have the phenyl group on an acyl chloride, so COCl, CH2, CH2, and the benzene ring. So this acyl chloride will be numbered beginning from the COCl carbon, so 1, 2, and 3. So the phenyl group is on the third carbon atom, so the name would become 3-phenyl propanoyl chloride. A phenyl group on an amide, CONH2. This is the amide group. We've got CH2, we've got CH2, and the phenyl group. Okay, let's replace another hydrogen on this compound with another substitute group. For example, let's place an OH group here. So now we've got a choice in the naming. So OH group stands for hydroxy and phenyl begins with a P. So hydroxy will be given preference during the naming of the compound. So 1, 2, and 3. So the name of this compound becomes 2-hydroxy 3-phenyl, and 3-carbon amide is known as propane amide. Taking another substituted group on a different compound. So if we have a phenyl group present on an alkene molecule, so we have C double bonded C, then we've got a CH2 group. So this will become CH and this will become CH2. So this is propene. And on the last CH2, we place a phenyl group here. So the numbering of this compound begins from left to right because the preference will be given to the double bond. So 1, 2, and 3. So the name of this compound becomes 3-phenyl propene. And that is how the benzene molecule is treated when it is present as a substitute group on a on an organic compound having another functional group present on it. There are certain organic compounds with the benzene group having another functional group attached directly to it, having specific names. So we need to remember those names. For example, if we've got a COOH group directly attached to the benzene ring, this compound is known as benzoic acid, and we need to remember this name. If we have this same compound, but instead of it being the acidic group, the acidic group reacts with a base forming a salt, for example, COO minus Na plus attached to the benzene ring. This salt containing benzene compound is called sodium benzoate. Another compound in which we've got Functional group attached directly to benzene would be COCl, which is the acyl chloride group attached to the benzene molecule, and the name of this compound becomes benzoyl chloride. Another compound in which we've got an NH2 group directly attached to the benzene molecule. This compound is known as phenylamine. Now, these names need to be remembered. There is no set logic to why they are named in this way, but these are special considerations that we need to remember. Another molecule with an OH group directly attached to the benzene ring is a molecule that is known as phenol. If we have a ketone in which one of the R groups is a benzene ring, this compound is generally known as an aromatic ketone. And if we have an ester in which the C double bond O single bond O ester group is attached to a benzene ring, this compound is known as a phenyl ester.